Hello and welcome back. Today we're going to learn about estimating decimals that are non-perfect squares. We're going to look at decimals that are non-perfect squares and we're going to estimate their roots. Okay, so let's start off the same way as always. We're going to write down a bunch of perfect squares that we know on top. So here we go. I have here, I'm going to have, we have 1 is 1, 2 is 4, 3 squared is 9, then 16, the square root of 16 is 4, 5 is going to be 25, 6 is going to be 36, 7 is going to be 49, 8 squared is going to be 64. Just separate these quickly. Okay, and then we have 9 squared is going to be 81, 10 squared is 100, and then we have 11 is 121, and we're going to have 12 squared is 144, and we have 13 squared is the square root of 166 is 13, or sorry, 169 is 13, and I'm going to have 14 is going to be 196, 15 is going to be 225, and then we're going to have the square root of 256 is 16, and now let's go 17 is 289, and we're going to just stop there for now. Or I think we have room for 18. So we have 324 is 18. Yeah, we just had enough room for 18. Okay, so we already had a couple lessons, or a few lessons ago. We did one on the perfect squares of decimals, okay? So finding a decimal, knowing if it's a perfect square or not. And if you remember, there were a couple rules we went over there. The first rule is we must have an even amount of decimal places. The second rule was we just look at the number up here and we find the perfect square up there, and then we just half the amount of decimal places, and that tells us how much decimal places we put our root, right? We half the amount of decimal places for the root as what was in our original number that we were square rooting. So now what we're going to do is we're going to look at a number maybe with only one decimal place, and a very tricky number. So let's try this one here. Let's say I want the square root of 0.9. Okay? So we're looking right here at the square root of 0.9. A lot of students automatically say, hey, this is the square root of, the root of 0.9 is 3, or 0.3. That's not true though, because if I was to go, I'm just going to move my paper up here a bit, if I was to go 0.3 multiplied by 0.3, that's going to give me 3 times 3 is 9, but two numbers behind the decimal places, so 0.09. It's going to end up giving me 0.09, not 0.9. So the square root of this is not actually going to be 0.3. So let's try and first make this so it has two decimal places. Because once it has two decimal places, it makes it easier, or an even amount of decimal places, it makes it easier to find our square root and use benchmarks like we did in the lesson just before. So let's go here. This is equal to 0.90. Okay? So in this case here, I'm going to do the same thing as I did in my estimating whole numbers, except it's with the decimals, but I'm going to ignore the decimals temporarily. So at 0.90, I'm going to make my bar and find two perfect square benchmarks, one below, one above. So one below is going to be 9, which is 81. And that is 9. And then one above is going to be 10, which is 100. Okay? Now looking at this here, here's the tricky thing. We have actually two numbers behind the decimal place. So this is 0.81, two numbers behind the decimal place. So that's going to be 1.0. And now we always have to half the amount of numbers behind the decimal place to find our square roots of a decimal. So half of this is 0.9. half of this, or we half the number, so move the decimal place 1, move the decimal place over 1, I get 1.0. So we know this is going to be approximately 0.9. But 0.9 what? I look at 90. How far is 90 between 81 and 100? Well, 90 is going to be almost right in the middle, so let's put 90 right there. Now altogether, between these, there's 19, right? 9 and 10. And we are 9/19ths of the way to a whole. So we are 9/19ths. I look at that, that's like 0.5. That's almost half. So this is going to be estimated at 0.95. And that's how we estimate 0.9. So let's try another one here. Okay, so let's try maybe 1.7. So I'm going to do the square root of 1.7. Now once again here, we can't look at 17 because we automatically have a decimal place, so I'm going to have to increase my decimal places. So I'm going to say 1.70. We need an even number of decimal places. So instead of 1.7, I'm looking at 1.70. All right? Now I look at 170. So we're going to pretend there is no decimal places and make my benchmark. So I'm looking at 170. Okay. So 170 is 13, which is 169. And we're going to have 14, which is 196. Okay. Now, we look at this here, 2 numbers behind the decimal, 2 numbers behind the decimal. So these are only going to have 1 number behind the decimal. We always have to half it for the perfect squares, right? If we take square root of 1.69, hey, that's going to be 1.3. We half the number. 2 numbers behind the decimal, 1 number behind the decimal. Now let's look at this here. I have 170. 170 is right here. Altogether, I have 27 of a difference because 13 and 14 is 27, and we're 1/27th of the way. So I could say that this is approximately equal to 1 point, I could say 3.1 or 1.30, anything like that will work. So let's look at one more. Let's look at square root of 281. So I'm going to write down square root of 2.81. So the square root of 2.81. Okay? Now look at 2.81. It is in between 16 and 17. So 2.56 and 289. 281 is not a perfect square, but it's in between these two right here. So now we know my benchmarks. We know one lower and one higher. So we have 2.56 and we have 2.89. Okay, and that's going to be 1.6 and 1.7. Now we look at this here, 281, where is that? That's all the way over here. Now, how far away are these things apart? So 16 plus 17 is going to be, it's out of 33. And we have 2.81. So 281 is 8 away from there. So we're going to have, that's just going to be a total of 25. Okay? So it's 25/33 of the way. Now looking at that, that is pretty good. I'm going to say that's around 80% of the way. So we know automatically this is going to be approximately 1.6, but we want one more decimal place. I'm going to say 1.68. I would allow 1.67, maybe even 1.69, but something like that. So we know it's way past halfway. So I'm going to say 1.68. All right? So that is how we estimate decimals. When we're square rooting decimals, that's how we estimate them. Okay, now, so let's reviewing what we are doing here. Step 1. We want to make sure we have an even amount of decimal places of the number we are square rooting. Okay? So if we have to add zeros, add zeros. Step 2. Once we have an even amount of decimal places, kind of ignore the decimal and see what are my 2 benchmarks on my perfect squares that are closest to. One just below and one just above. Okay? Step 3 is going to be write the number line. So like we did for all of these, we made a number line. Now, the thing is, when we put our number lines, when we put our numbers on top, we're going to half the number of decimal places. That's how we know how many decimal places over. Next step is going to be we start taking the fractions and seeing how far over it is to put in my next decimal place unit for my estimation. And that is how we do estimating of non-perfect square roots that are decimals.